Hello, this is Jane with Second Wind Nation. Thanks for joining us. This is a tape or a video on how to achieve asymptotes. This is for people that are doing college algebra or pre-calculus. If you're interested in learning how to do an asymptote, or you're getting to a place where you need to learn how to get the intercept of a line using rational functions, you can use this as a guide or an aid to help you along with your actual study. So these are going to be in Lane's terms. Just know that you just use these as guides or aids to help you get through understanding how to use the information that you have on your regular assignments. So we'll start with the horizontal asymptote. What we want to do is try to get a horizontal line going here using the rational function. So the rule is when you're looking for the horizontal asymptote, what you want to do is go by these three rules. You have a top is less than the bottom rule. You have a top is equal to the bottom rule, and you have a top that's greater than the bottom rule. So just remember to start it all off with tops when you're doing a horizontal, and the top is either less than, equal to, or greater than the bottom. So just know we're referring to the numerator and the denominator. So right now we're focusing on the numerator, and we are also focusing on the power of that numerator. So when you're looking for the horizontal asymptote, you're looking for its highest power. So that highest power will let you know how to work that asymptote in getting the y asymptote or the vertical asymptote, or excuse me, the horizontal asymptote. So the horizontal asymptote goes like this. If the top is less than the bottom in the power of the coefficient, just know that the bottom here is bigger than the top because it's x of 2 and this is x of 1. So the numerator is smaller than the denominator. Your y-intercept is going to be 0. So there would be no y-intercept. So just know that automatically anytime you see that the top leading coefficient is smaller than the bottom leading coefficient, that the y-intercept is equal to 0. Okay, so that takes care of the top less than the bottom. Now number 2, we're going to go to the top is equal to the bottom. So doesn't matter what the leading coefficient term is, as long as the coefficients are the same. So at this time we see that even though the coefficient to x squared is 1, or understood to be 1, and it's less than a 3 at the bottom, that's okay. So just know that this will let you know that they're equal as far as power, because we're only concentrating on power when we are looking for the horizontal asymptote. So you take these two numbers, the 1 and the 3, and you use those to make your y intercept. So at this time we see we take the leading coefficient of the numerator over the denominator and make it y equals 1 over 3, or 1/3. So that will take care of how you do when it's equal. Always use the leading coefficients, how you say, integers, to determine what the answer would be. You don't need any of the other terms or information. You just need the leading coefficients, how you say, integers or numbers, whole numbers that are here. For the numerator is 1 and the denominator is 3, so that leads us to 1/3, and that's all you need, and that's all you will use to make this vertical asymptote, or should I say horizontal asymptote. So this is the horizontal asymptote for when it's equals 1/3 for this particular problem. We're going to go and see what happens if the top is greater than the bottom. So if the top is greater than the bottom in power, you would just know that there is no horizontal asymptote. So if there's no horizontal asymptote, your answer would simply be none, no asymptote, or none, there are none, or any asymptotes, or something to that effect. Whatever your teacher have you. A lot of people will abbreviate and use HA. Just know you'll need to refer to your instructor to find out what's appropriate for an answer on any question, as a matter of fact. So there are certain ways your questions needs to be taken care of. It could be integers, in parentheses, or how you say set notations, or the like. So there are certain ways, even if you're doing the square roots and you need to leave the radicand over the number if it's to be the plus equals 2, that we'll go into that later. Just know there are certain ways that you have to have the answer. So in our class, no asymptote is horizontal asymptote is usually was allowed. Now we're going to go to the vertical asymptote. So sorry, I spelled wrong. So the vertical asymptote will be dealing with the denominator. So whereas we were looking for the power in the asymptote for the horizontal, we'll switch and do something totally different for the denominator to find out the vertical asymptote. So we'll concentrate on the denominator here. So the first rule is the factor. So we'll take that vertical, the bottom or the denominator, and factor it out. So at this time we need two numbers that multiply together to equal -32, but add up to equal -4. So we can use those two numbers to use as factors. So we'll take this x and split it up in 2 and place that x in one of each of the parentheses. And so at this time we'll notice that if we were to multiply -8 times 4, it would give us -32. But if we were to add -8 plus 4, it would give us -4. So that's how we know that we got the right numbers. We set each of these terms or expressions to equal 0. So we'll bring it down if we can't further cancel anything out. So they happen to be different. They're not the same, so there's nothing to cancel. That's our second rule from factoring. We go to cancel for vertical asymptotes. Sorry, that's spelled wrong, but vertical asymptotes have these rules: factor, cancel, and then set the denominator to equal 0. So those are the three rules that you will follow to take care of the vertical asymptote. So right now we'll set both of these down here to equal 0. So we have the, sorry, that's a little dim down there, but the x, so we have the x plus 4. We take it out of the parentheses and set it to equal 0, then subtract the 4 on both sides, so that x will equal -4 for our first vertical asymptote. And then our second vertical asymptote will set 8 minus, or should I say x minus 8 to equal 0, and then add 8 on both sides. When we add 8 on both sides, that would give us a positive 8. And that would be x equals 8. To get the variable alone, what we'll do is do the subtraction or adding. It just depends on what this sign is. So anytime you see it set to 0, I always know to do the opposite. See, you need to move this on the other side of the equation. So that what you call constant, or term that stands alone, needs to go on the other side of the equation. It cannot be factored anymore. There's no other type of work that needs to be done to it. It's in its final stage. The only thing we need to do now is find out how x can equal 0. So to get it to equal 0, if we were to add -4 plus 4, that would make this true. That would be equal to 0. So that's the reason for that. We want to know what line on the x-axis will be at 0 point. So say we had an x-axis, just a little rough draft here, and say this point right here was -4, and this point right here was 4. Very, very rough, just to give you an idea of what I mean. When we land here on -4, basically what happens is this is our 0. We start here, that 0 line moves here, and then just know that if we were to go the opposite direction to 4, we will land here. So the 0x will now be 4. But if we were to take 4 from 4, we will land on neither. So that means that there will be no intercept or x or any of that, because this cancels this out in this problem, making it 0. Then there will be nothing on here. That, in other words, there is no intercept. So to get it to that point, we would have to cancel this number out and make it -4, which means that that x will be 0 at -4. So this will be our 0 line. In other words, lines on a graph can represent 0 for a start. So if I need to graph something that's at 4 as a start in my 0, just know that that would be my starting point. So all starting points are considered zeros on the axis itself. So just know that any point, line horizontal or line vertical, can be a 0 for a starting point. So we'll look at those as 0. So that's the concept behind numbers meaning zeros, or equaling to 0, or getting to a 0, or finding a 0 on a line, or 0 on a point. So if you hear these type of jargons, just know all they're saying is that that's where you need to start. Don't start at the 0, 0 for the x and y. The x and y will have its own 0 for a starting point, depending on what you're trying to figure out. So just know if you're doing piecewise work, you're trying to do rational functions, you're trying to do simple quadratic equations that are the like, always know that where you intercept, where your line intercept, or where your answer is lying on the graph to start with, is considered your 0. So that'll be your starting point. Just know that there's lots of information on the internet that goes into detail. My goal here is to give it all in one, so that way you don't go have to hunt around for this part of the information and that part of the information. What I try and do is jam pack my videos with a host of information to hopefully help you solve some problems without going to hunt for this part, that part, and then now what. So please come back. Like if you share, that'll be great. And if not, just enjoy the video, and I hope you get something out of it. And if nothing else, just add it as an aid or a guide to the homework that you're doing. This is Jane and Ladybug with Second Wind Nation signing out. Be blessed.